Good morning everyone. My name is Nikhila. I'm from BIT College studying in 3rd SEM CSE branch. Today I'm going to explain about determination of minimum expressions using essential prime implicants. It is a topic of K-maps. So first let's study about the K-map. K-maps are the graphical methods used to simplify Boolean expressions. They provide a visual representation of a truth table, makes it easier to identify and group adjacent cells containing ones. These groups correspond to simplified Boolean expressions. That means K-maps are used for visual representation of truth tables. These groups are simplified Boolean expressions. They used to simplify Boolean expressions. Next, key steps involved in using K-maps. First one, create a K-map. The size of the K-map depends on the number of input variable. That means we can use two input variable, three input variable and four input variable. These are the main input variables which we use. Fill the K-map. Place ones in the cells corresponding to minterm where the function output is 1. We have to place ones in the corresponding input where the input will produce output 1. Group of ones. The adjacent group of 1, we should group the adjacent ones in the power of pairs and quad and octa. That means we have to take 2 or 4, 8 groups of ones. Write the simplified expressions. For each group, identify the variable that remain constant, combine that variables using AND operations, and combine those groups using OR operations. That means we have to identify the variables that remains constants and we have to combine those variables using AND operations, and those AND operations we used to combine by using OR operations. Why use K-maps? Because it is simplified efficiency and clarity. Simplification means the K-maps minimize the Boolean expressions. That means it is used to minimize the large Boolean expression into simple digital expressions. Efficiency. By reducing the number of gates, K-maps contribute more efficient and cost-effective designs. It is used for cost-effective designs. Clarity. The visual nature of K-maps makes it easier to understand complex Boolean expressions. We can understand complex Boolean expressions using K-maps. Next, how K-maps works. First one, create K-map. The size of the K-maps depends on the number of input variables. That means, for example, 2 input variable consists of 2 into 2 grid, 3 input variables consist of 2 into 4 grid, and 4 input variables consist of 4 into 4 grid, and so on. The cells in the K-maps are assigned arranged in specific order, ensuring that adjacent cells differ by one. The arrangement facilitates groups of adjacent ones. That means the K-maps are arranged in a specific order in which the adjacent cells is different by one. Fill the K-map. For each minterm, place a 1 in the corresponding cell of K-map. For each minterm means input combination that produces 1. We have to place 1 in that corresponding cells. Group of ones. The group of ones are grouped by 2, 4, 8. That means the ones are grouped as pairs, quad, and octa. A group should be large as possible. They can wrap around the edges of the K-map. That means we can wrap the groups around the edges of the K-maps. Write the simplified expressions. For each group, identify the variable that remains constant within the group. Combine those variables using AND operations. Combine those simplified expressions using OR operations. Like I said, for each group, we have to identify the constant variables. Then we have to combine those variables using AND operations. Then we have to combine those simplified expressions using OR operations. Advantages of K-maps. It is simplification. The K-maps provide a symmetric way of simplifying Boolean expressions, leading a fewer logic gates and efficient circuits. That means K-map provides systematic way of simplified Boolean expressions, leading a fewer logic gates and more efficient circuits. Visual clarity. The K-map representation makes it easier to understand relationship between input variables and output variables. This graphical K-map graphical representation is used to show the relationship between the input variables and the output. Error reductions. K-maps reduce the error, mm, which are with K-maps reduce the human error chances in manual simplifications. Limitations of K-maps. Complexity. For larger functions such as 5 input variables, 5 to 6 input variables, 7 input variables, K-maps can become complex and difficult to visualize. So mainly we use 2, 3, 4 to overcome that problem. Don't care conditions. While K-maps handle don't care condition, it may always be straightforward to identify the optimal grouping strategy. Don't care conditions means we can take it 0 as or as 1. So it may be straightforward to identify the optimal grouping strategies. Understanding the basics. Prime implicants. A group of minterms that cannot be further simplified by combining with other groups. Okay, next essential prime implicants means a prime implicants that covers at least one minterm that cannot be covered by any other prime implicants. Steps to determine minimum expressions. First one, create a K-map. Group of minterms based on the number of ones is binary representation. Place the minterms in the appropriate cells of the K-maps. Second one, identify the prime implicants. Circle groups of adjacent ones starting with the largest possible groups. That means we have to group the ones in the largest possible groups. Each circle group represents a prime implicant. The each circled group of pair or quad or octa that represent the prime implicants. Identify the essential prime implicants. Look for the minterm that is covered by only one prime implicant. The prime implicants covering those unique minterms are essential. That means they that means a prime implicants that is not covered by any other groups. It is called as essential prime implicants. For the minimum expression, include all the essential prime implicants in the expression. If those remaining minterms are not covered by the essential prime implicants, select the additional prime implicants. Minimize the total number of literates. Okay. Essential prime implicants. In a realm of digital logic design, simplifying Boolean expression is a crucial for designing efficient and cost-effective circuits. One of the most powerful technique to achieve is identifying and utilizing essential prime implicants. That means in a digital realm of digital logic design, simplifying Boolean expressions is crucial. It means difficult. It is difficult to simplify the Boolean expressions. In that, the most one of the powerful technique, which is design efficient and cost effective, is utilizing and identifying essential prime implicants. First, what are prime implicants? A prime implicant is a group of minterms that cannot be further simplified by combining with any other groups. In K-map, prime implicants are represented as rectangular group of ones. That means a prime implicant is a group of minterms which is the input combination that produces one output that cannot be further simplified by combining with other groups. In K-map, the prime implicants are represented in regular groups of ones, rectangular groups of ones. That means the prime implicants are represented as rectangular groups. What are essential prime implicants? An essential prime implicant is a prime implicant that covers at least one minterm that cannot be covered by any other prime implicants. In other words, the group of ones that is essential for simplified Boolean expressions. That means essential prime implicants. It consists of prime implicants that covers at least one minterms that is not covered by any other prime implicants. Why are essential prime implicants important? Minimal expression, efficient circuit design, and reduced propagation. Minimal expressions means by identifying and including essential prime implicants in the specified expressions, we can ensure that resulting expression is minimal. Efficient circuit design means a minimal expression translate the fewer logic gates, leading to more effective and cost-effective circuit. Reduced propagation delay. Fewer logic gates means shorter signal propagation paths, resulting in faster circuit propagations. How to identify essential prime implicants? Like we have discussed earlier, first we have to create an K-map and we have to identify prime implicants. Then we have to check for essential prime implicants in those prime implicants. For example, check the unique coverage. For each prime implicant, examine the minterms it covers. If a minterm is covered by only one prime implicant, then that prime implicant is essential. Now, this is an this is the example for three input variable K-map. The question is f of a b c is equal to summation of m of 1, 3, 4, 5, 6. That means we have to place 1 in these 1, 2, 1, 3, 4, 5, 6 cells. Then we get this K-map. For this, we we have to check for essential prime implicants that is given in next slide. This is the K-map analysis for the three input variables which I shown earlier. The K-map presents the Boolean function of f of abc is equal to summation of 1, 3, 4, 5, 6, which we have placed once in those places. Grouping of ones means in which the group 1 is BC, it covers the minterms 1, 3, 5, and 7, and group 2A that covers the minterm of 4, 5, 6, 7. Simplified expressions means f of ABC is equal to BC plus A. Essential prime implicants, in this case, both are essential prime implicants because each covers at least one minterm that cannot be covered by other groups. That means it is a prime implicant. It is an essential prime. The both groups are essential prime implicants, which means it means which covers at least one minterm which cannot be covered by other groups. This is the example of four input variable K map. These are the combinations of one which produces output one. This is don't care conditions. This is the truth table of that four input variable K map. In this K-map diagram, we can see that the ones are grouped into a quad. This one is also a quad with the help of the don't care conditions. We can also use don't care condition for using maximum possible group number of grouping. And this is also if we don't use the don't care conditions, it is only given circle for only one digit. So we have taken x to make it as a pair. So next, let's see the K-map analysis for this one. This is the K-map analysis for the four input variables which I showed earlier. The f of a plus b is equal to summation of 3, 7, 5, 10, 11, 13, 15, and these are the don't care conditions. The D term means the don't care conditions. We can assign either 0 or 1 to simplify the expression further. Grouping the ones and don't care conditions, we can group 1 is A bar, B bar, C. It covers the minterm 3 and 2. Group 2 BD, it covers the minterm 6, 7, 13, and 15. Group 3 A, B bar covers minterm of 8, 9, 11, and 12. After combination these groups, we get the simplified expression A bar, B bar, C plus BD plus AB bar. In this, the prime implicants are A bar, B bar, C plus BD because these essential prime implicants are not covered by any other prime implicants or any other groups. So this is what we call as prime implicants. I hope you understand. Thank you.